Hello and welcome. In this video, we are going to solve problem number 31 of Leetcode, that is next permutation. So let's go to the description and try to understand this problem. So a permutation of an array of integer is an arrangement of all the members into a sequence of linear order. Okay, so for example, if we have an array of 1 to 3, then all the permutation will be something like 1 2 3 1 3 2 2 1 3 2 3 1 3 1 2 3 2 1. Okay, so we have to rearrange all the elements of this array in different order and make sure that n- none of these will be get repeated. Okay, so this is going to be our permutation. Okay, so the next permutation of an array of integers is the next lexicographically greater permutation of its integer. More formally, if all the permutation of the array are sorted in one container according to their lexicographical order, then the next permutation of that array is the permutation that follows it in sorted container. So what does it mean? So let's say this these all are permutation. So if you arrange these in sorted orders, you can see that this is already sorted. So if you are find the next permutation of this 1 2 3, then you can see that the next permutation in this sorted order will be 1 3 2. Similarly, for 1 3 2 2 1 3 is going to be our next permutation. So we have to find out the next permutation. We have given some permutation of a number and we have to find out the next permutation in this problem. So we have given 1 2 3. Okay, so what will be the next permutation? We can see that 1 3 2 is going to be our next permutation, and similarly for 3 2 1, what is going to be our next permutation? So this is you can see that this is the last permutation that we can have in a array, array of 1 to 3. Okay, so this is the last permutation, so there is no next permutation for this. So in that case, what we have to do, we have to, while the next permutation of array is 3 to 1, does not have lexicography the larger element. So in this case, what we have to do, we have to do return the next permutation from beginning. That is, in this case, it will be something like 1 2 3. So in this case, we have to only reverse and return the result. Okay, so this was the description, and I hope you must have got some idea about the problem. Now we will try to solve this problem and try to understand a bit more. So how you can solve this problem? So one way is to find all the permutation and in sort order, and then return next permutation. Okay, so for that we have to find the permutation in the sorted order. So first, either we can find the permutation of all the numbers, then we can sort it, and one way is to first sort the array at beginning and then find the permutation of all number. Okay, so this is going to be better one than finding and sorting. So first we will sort this and then find the permutation. So you can see that this is going to take a larger amount of time. Like we have to use, for this we have to use recursion plus backtracking. Okay, and this is not the best approach that we can come up with. There is a another method that we can solve this problem with. So let's go for that method. So let's write the permutation of our different numbers, something like 1 2 3 4. So what will be the permutation of these if in sorted order? So first permutation will be 1 2 3 4, the next one will be 1 2 4 3, the next one will be 1 3 2 4, and then 1 4 2 3 1 4 3 2 2 1 3 4 2 3 1 4 2 3 4 1 2 4 3 1. Okay, and the next one can be 3 1 2 4. Okay, so these are all the permutations that not all the, but few permutation, few initial permutation. There will be many more permutation in this case, so we have written the only few one. Okay, so let's see how we found out this permutation, how we make sure that the next one is just a greater one or not the not. So like if we find out the permutation, the next permutation for 1 2 3 4, then it will be 1 2 3 4 3. Okay, so how we make sure that it is going to be 1 2 4 3. Is there any changes we can see in these all the permutations? So we can see that we have swapped these 3 and 4 in this case. So now it become 1 2 4 3. In this case, what we saw that 1 2 1 3 2 4, we did something like we swapped 3 and 4. Okay, and we got this permutation. In the next case, we can see that we swapped 2 and 3 and we got this permutation. In the next case, we can see that we swapped like first we swapped 1. We can't find out the next permutation. In this case, we can't find out the permutation simply by swapping any two number. Okay, so we can see that there is some other approach that we have to follow. Swapping will not going to work for this case. So what is that approach? So we can see that here. So what we did, so from 2431 we had to find out 2431, we had to find out 3124. How we can find out? So we started from the last index and find out the first decreasing number. Okay, so we started from here and then we can say that this is going to be our first decreasing number. We have to mark that, and then let's say it is kth index. Okay, and then again we started iterating from beginning, and we find out the first number which is greater than this number. So you can see that this one is the number. Let's say it is I. Okay, now what we did, we swapped these two number. After swapping this became 3 4 2 1. Okay, and then we reversed all the sub arrays after the index k. So let's say sub arrays after the index k 2 4 2 1. Okay, after reversing this become 1 2 4 and keep the 3 at the beginning. So we can say this is our result. Okay, let's see whether this method follows in all the cases. So for the first case, we find out the first decreasing number, that is 3. Again, we started from beginning and found out the first number which is greater than these numbers, which is going to be 4. Now we swap these two, this became 4 3, and then we reverse the number after k. So after reversing 3, it becomes 3 only. So this follows. For same for 1 3 2 4, let's say we found out the first decreasing number here is 2, and then we found out the number which is just greater than this number, so which is going to be 3. Now we swapped these two. After swapping this became 1 2 1 3 4 2. Okay, and then what we did, we reverse all the number after index k. So after reversing this become 1 3 2 4. That is our result. Okay, same for any case you can check, that is going to be follow. So this is the approach that we are going to follow. Okay, you can see that we don't do any recursion and backtracking type of thing. So this is going to be very less time consuming in compare of previous approach. Okay, so let's write the pseudocode for this. And so first what we did, we iterate from last and find first decreasing number. Okay, so what if you will not found any decreasing number, let's say 4 3 2 1. So in this case we will not be able to find any decreasing number. You can see that from last it is going to be increases only. So in this case what we have to do, we have to reverse this array and reverse the array and return result. So in this case, and if not found, reverse array and return result. Okay, then after finding the first decreasing number, what we have to do, we have to find out, iterate from last. Again we have to iterate from last, iterate from last, and again find out first number which is just greater than, let's say it is the kth number, we marked it as kth number. Okay, we find kth number. Okay, number at kth position. Okay, and then what we do, we swap, let's say this is going to be our ith number, swap ith and kth number, and then after we will be reversing, then reverse sub arrays from index I k plus 1. Okay, so this is a pseudo code that we have to follow and write the code for same. So let's go to the compiler and write the code for same. Okay, first we'll find out the length of the array, that is num n equal to num dot length, and we have to iterate from last index, as we have to compare the compare the current number with the next number. So we have to iterate it from I equal k equal to n minus 2. Okay, and start iterating until unless we will find out that I is greater than equal to 0 and nums of I is greater than equal to nums of I plus 1. Okay, and this is not I, as we have started our index from k, so sorry for that. Yeah, and till then we'll be doing a k minus minus, and if the second case, if we find out that k no decreasing number is found, then in this case k will be lesser than 0, and then we will be doing reverse, as we don't have to return anything, just reverse nums with index 0. Okay, in else part what we have to do, we have to find the first number which is greater than the current kth number. So again we will be start from I equal to n minus 1, and start checking from last until unless I should be greater than j and nums of I is greater than equal to nums of k. Not greater than equal to, we have to find out the first greater, not this, it should be lesser than equal to. Why? Because we have to find out the first increasing number which is greater than our current kth value. So that's why we will be doing less than equal to in this case. Now do k minus minus, sorry, not k, I minus minus, and here it will be something like I should be greater than k. Okay, and then after this what we have to do, we have to swap our these two I and k. So swap a nums I k, and at last reverse our array from index k plus 1. Okay, now what we have to do, we have to implement this swap and reverse function. So let's go here and first write the code for swap. Okay, so we'll be doing int temp equal to nums of a, and nums of a is going to be nums of b, and then nums of b is going to be temp. So we have swapped this, and now we have to implement our reverse function. So for that we'll be doing private void reverse from kth index. Okay, now implement this, so we can say it is a left index. Okay, so this is the left index, and we have to reverse from left to all the remaining integers. Okay, so what is going to be our right index? Right index is going to be nums dot length minus 1. So from index left to right we have to reverse our array. So we'll be doing while loop, while left is lesser than equal to right, we have to swap the numbers, swap nums left and right. We can help of this swap function that we already implemented here, and then till then keep implementing right minus minus, and left plus plus. Yeah, as we don't have to make sure that if left is equal to right, then we don't have to do any swap. That is not going to be any helpful in this case. Okay, like if you are swapping only same number, then in that case it is going to be the same ones. Okay, so we are not going to swap that. So we'll be checking only till left is lesser than right. So now run this. Yeah, so all given three test cases has been passed. It's time to submit this solution, and let's check whether our solution has been accepted or not. Yeah, our solution has been accepted, and this is one of the most optimized approach that we can come up with. And you can see also the solution beats 100% of the solution. And I hope you must have learned something from this video. In that case, please make sure to like the video, subscribe to the channel, and don't forget to share this video among your friends. Thank you.